floating freely through solar systems as they ingest and absorb matter, energy, and rays from around space. Black holes have always been one of the most puzzling discoveries by scientists ever since the 1990s about the world outside our planet. With no regard to matter around it, and seemingly always finding a way to twist the laws of physics, black holes are phenomenal chaos that continue to reshape the way we look at them, with every discovery about them raising so many questions with only a few answers. So what are black holes all about? Where did they first form, and how big was it? And if black holes follow the logic of increasing size with whatever they engulf, does this mean they will keep eating everything in the universe until there is nothing left? And if not, then how big can they get? The first were discovered as a darkened mass ripping apart space as it ingested masses even a lot bigger than itself in a very vigorous spiral pattern. The phenomenon was discovered by astronomers in 1964 as they noticed signs of gas being drawn away from a big blue supergiant star in its orbit. This gave way to the creation of Cygnus X1, which is tagged as the first discovery of black hole formations by humans, roughly 7,000 light-years from Earth. Scientists believe that the creation of black holes started as early as after the Big Bang, to which much smaller black holes were created, ones as small as atoms, and even smaller known as quantum black holes. Though it is believed that these microscopic black holes were relatively harmless and would die away moments after birth, as they would be a lot hotter than our Sun and would evaporate to nothing. Now it is speculated that there are over 100 billion black holes in space, and still more to come. Before diving deeper into the existence of black holes and their size expansions, you need to understand what black holes are and what it would take to escape their gravitational pull. Throughout the years after the discovery of black holes, many have fantasized about what was hidden inside those big spaces of darkness, with theories of them being a portal to other dimensions or the passage to an afterlife. Even scientists were puzzled by their existence. As time passed and research progressed, scientists have been able to understand more about black holes and what goes on inside of them. Although there is still no full conclusion on what may lie on the inside of a black hole, science has explained black holes to be formed from a point of gravitational singularity, a region where the space-time curvature becomes infinite. To explain that in simple terms, gravity and density become infinite, and space-time stretches with no end. From this point, science believes black holes are formed from this phenomenon, from which continues stretching farther and farther, trapping matter and energy in its strong gravitational pull, which experiences the spiral motion predominantly seen, and eventually trapped in a point of no return, squeezed alongside more matter being pulled in. While on the topic of gravitational pull, what would it take to escape the strong magnetic pull that wraps matter into black holes? You probably aren't surprised to know that currently there isn't anything discovered capable of withstanding the gravitational pull of a black hole. Or to put it, there isn't anything with force propulsion faster than the speed of light to surpass its gravitational pull. Black holes, like Earth, carry a certain amount of gravitational attraction in which to escape. The object caught in this attraction would have to release a much higher amount of force beyond that of the gravitational attraction. You could apply that sense to occurrences on Earth. Just as a rocket being launched into space would have to possess enough force needed to withstand and push past the gravitational pull of Earth's surface, known as the escape velocity, that same rocket would need to release the relative amount of force needed to escape a black hole's gravitational pull. The minimum speed needed to escape the Earth's gravitational attraction is 11.2 kilometers per second, or 6.9 miles per second. The stats are then changed when escaping a black hole, as the rocket would need to possess an escape velocity faster than or equal to the speed of light. In this case, nothing ever discovered or created possesses that speed, making it impossible to achieve. Scientists from NASA have been actively and closely studying cosmic bodies and black holes over the years. Through this, they gain data which they use to compare and measure solar sizes, impact, birth time, and other physical properties of black holes. In the past, it was believed that black holes had a limited mass to which they could expand, but recent studies have combated that theory, as space exploration led to the discovery of much larger black holes in our solar system. Incredibly, it has been measured that an ordinary stellar black hole is proportional to the size of 3 to 10 of our Sun combined. The Cygnus X1, having a size proportional to the combination of 21 solar masses, is still pretty small compared with other larger black holes. The next in line for larger-sized black holes are known predominantly as intermediate mass black holes. This was a wave breaker in discovery, as it opened up doors to more possibilities in space studies and explained more about black holes. As the name implies, these black holes exceed the size of our Sun with massive depth, having a size proportional to hundreds or thousands of our Sun combined. Using a satellite to detect the rays released in the disk of a black hole, scientists in 2006 detected a strong signal of rays pointing to the potential of an existing huge black hole. The signal detected led them to a dense star cluster in a different galaxy, and with the signal ratios, scientists were able to calculate the size of the black hole, which was proportional to the size of 50,000 of our Sun combined. You might be thinking that's a whole lot, but would be shocked to realize that the number only increases when dealing with supermassive black holes. The next mind-blowing size range known for black holes is the supermassive category that are giants in their making. An example from this size category includes Sagittarius A, which is a black hole sitting right in the middle of the Milky Way, which has been measured to comprise a size of 92 intermediate mass black holes combined. Keep in mind that one intermediate mass black hole comprises a size of 50,000 of our Suns combined. Even with such a mind-boggling size, Sagittarius A is not that big, actually being only 17 times larger than our Sun. It's said that it could even sit in Mercury's orbit. Currently, Sagittarius A is about 26,000 light-years away from Earth, so there's no need to fear having our solar system disrupted by its presence. Ever heard of 3C186? This supermassive black hole is termed by many scientists as strange. Pictures taken by NASA show the strange black hole sitting about 8 billion light-years away in its distinct solar system as it shines abnormally bright. What's even more strange about this black hole is its positioning in its solar system, which is about 35,000 light-years from the middle point, which is farther than our Sun is from the Milky Way. With an estimated weight of over 1 billion suns, what could have possibly shot this supermassive black hole further away from the center of its solar system? Scientists have theorized what could have happened which caused this abnormal fixture. It is believed that in a phenomenal event, two solar systems crashed into each other and collided with time about 1 to 2 billion years ago. In this event, both middle points collided with each other and merged into one, creating a jolt of gravitational waves, which partially pushed away the black hole further from its center. Think of it as a massive explosion in the sky that pushed back the black hole further away, to which it still is on the move, as 3C186 is still moving away from its center at 7,500,000 kilometers per hour. What is incredible about all this is that this black hole could travel to the moon from our planet in roughly 3 minutes. As we know, black holes feed on stars, gas, and most likely anything in their way floating through the galaxy. Through this phenomenon or habit, it can grow extensionally to massive width and lengths, even bigger than the mass of smaller stars you would call gigantic. But don't be fooled. Black holes aren't some sort of vacuum that cleans up after everything. In fact, if they were to replace our Sun, Earth and other planets would orbit them just fine. This is because our planet would have to be much closer to it to be caught within its gravitational attraction. Still, if you are looking for a black hole capable of doing a better job at vacuuming, the ultra-massive black hole. The biggest one ever discovered that shocks even the bravest of scientists is the ultra-massive black hole. Imagine Sagittarius A, which makes our Sun look like an asteroid, placed next to them and looking like an asteroid itself. Home 15A Galaxy is home to one of these giants, as the galaxy itself has over roughly 2 trillion solar masses. A black hole like this has a size proportional to the size of 40 billion of our suns combined, or 43C186. If that's not a good enough comparison for you, it's more than half the number of the stars in our solar system put together. Sitting 700 million light-years from us, a hole in the center of the galaxy equals the size of our solar system. Another great comparison is the TON 618, which is 60 billion suns of ours combined. And if that's too much for you to understand, say it's more massive than all the stars in the Milky Way combined. This monster of a black hole is located in one of the most giant galaxies known, which is a quasar brighter than its galaxy. Many still speculate about the origins of this black hole, with a lot of theories going around. Computer simulation shows a combination of black holes altogether, but still, there is no confirmation on that. However, TON 618 is still the biggest black hole ever discovered. Still, scientists have been discovering more and more black holes, to which they have even made a new category to fit them in: the stupendously massive black holes. While the black holes seem to keep growing and growing, many have asked whether this means that they are eternal. For the most part, it is believed that they are, or at least even after the death of all stars, black holes will remain furthermore. And the bigger they get, the longer they stay. Black holes do experience a phenomenon where they release some matter from their masses, known as the Hawking radiation, but still, even with this, the bigger the black hole is, the slower this process is. As of now, there are still a lot of questions about black holes to be answered, most of which are, what happens once you're inside? As technology progresses, we hope to understand more about life as a whole, and more about what goes on inside of a black hole. But until then, black holes will always be the most mysterious part of the world outside our planets.